Hello guys, my name is Divesh Jadwani and welcome to my YouTube channel. So guys, in this particular video, we are going to talk about a very exciting and a very trending topic which no one has really talked about right now. This is OpenCV 5. It is the most latest version of OpenCV. It has brought drastic change and the future of computer vision is gonna change completely after this particular time. We are going to study OpenCV completely. We are also going to study some good demonstration. Every link, everything, every resource is going to be shared with you. So I'm pretty excited for understanding all of these things, and let us dive right into this. Welcome to this particular class, and what we are going to study today is OpenCV 5. Okay, what is OpenCV 5? OpenCV 5 is the fifth revolution in the OpenCV industry. Okay, what is OpenCV? First of all, it is a framework. Okay, OpenCV is an amazing framework for your computer vision tasks, for processing computer vision models. Okay, this is the bottom line of OpenCV. If you don't know what is OpenCV, I'm just going to talk about it one more minute. So see people, currently in the phase we are living in is called the agentic AI phase. Now agentic AI phase comes under the generative AI phase. Okay. Now generative AI phase comes under the deep learning phase. And deep learning is the real AI. All right. Deep learning is where it all started. Deep learning is the place where it all started to change. Okay. It was deep learning when we made a deep neural network for making that transformers architecture. Once we made the transformers architecture, that is when your AI agents and everything started to come into picture. Because, and again, transformers started with NLP and then automatically it went to the computer vision. Okay, computer vision. So we have to understand this very properly, that deep learning is the real artificial intelligence. Currently, yes, we all have been talking about agentic AI, generative AI, making AI agents, etc., etc. But let me tell you this, okay? This is not AI engineering. I mean, yes, don't take it the wrong way. This is of course AI development and everything, but this I would like to put as more of a software engineering, because what we do in the softwares, we take already made things, already made components, and we make it into a software. All right, for example, if we want to do project planning, so we have a Jira board ready, we will simply use that Jira board. Okay, we want to do communication, Slack is ready, we are using Slack. Okay, we want to fetch messages from Slack API, etc., etc. In the end, in the agentic AI phase, I know it's a lot of hype. We have these beautifully performing large language models. What are we doing in this agentic AI space? We are just using these models via an API. Okay, what about the part of building deep learning models? I'm talking about giving birth to AI models. What about that part? Because that is real AI, that is real deep learning, giving birth to new AI models. All right. So the current population is really driven with to making AI agents and agentic AI and everything. But again, this is just picking pieces and putting pieces together to form a chain. We are doing great, we are building great solutions. Okay, we are building great solutions, because now it has become very easy for any developer to build great solutions. But we have to know the real thing, deep learning. Okay, why deep learning is important? Because we want to make our devices intelligent. Okay, devices, intelligent devices. Currently, who is becoming intelligent? Our software applications are becoming intelligent. Our software apps are becoming intelligent. What about making your devices intelligent is where am I taking this class towards. Okay, so what do I mean by this? So we all know recently Maharashtra government or Goa government, any kind of Indian government or other governments as well, they have pulled up this thing called as license plate detection, and this is heavily used. Okay, this is heavily used currently, and using this license plate detection, if you break the rule, all right, you directly get a challan, or you directly get a fine that you have to pay on your mobile number. Right now, how does this happen? There is a road. Okay, there is a road, there are CCTV cameras placed on the signals, and if you break the road, okay, if you break the rule while there is a signal, your license plate will be detected, and you will be sent the you know you will be sent the fine. Right, this is a classic example of computer vision. I'm starting the class, I'm taking this towards computer vision. Okay, and I'm talking about real AI engineering. Okay, real deep learning, because that is where it all started. And please never think that this is gone. Okay, this will never be gone. We will always keep giving birth to AI models. Yes, population will keep on using them more. So earlier when I talk about the deep learning or the AI community, okay, 100% of the people were building models. But since the rise of agentic AI, this has directly reduced to 30%. It is 30% people who are building AI models, and rest all the crowd is running behind the hype of using those models for agentic AI and hype and everything. Okay, maybe I might be wrong over here, but I have seen a huge population shift wherein people don't want to know deep learning. They directly want to learn Python. They directly want to start using generative AI, because LLMs are very easy to understand these days. It is just the matter of understanding input and output. We directly refer this to as some intelligent model. We never went in the history of how it actually happened. And this is what real data science is. Okay, this is what real data science is. We never want to forget our roots, where it all started, because in the future, this is very important line. Okay, currently we have global market leaders, global leaders, and we all know the entire community is dependent upon Claude. We are dependent upon Microsoft Copilot. Okay, and we are also dependent upon Gemini and other things. What if these particular organizations said that we don't want to give our models in your country, we don't support in your region, we want to do some cost cutting? Okay, in this particular scenario, what about your country? Okay, will there be any people who know how to train deep learning models, or entire population is filled with only using those models? Okay, we have to draw a line over here. And so that is the whole importance, that we never want to forget deep learning. Now, where am I taking this towards? Deep learning is giving birth to new AI models. Now, what these AI models do? These AI models do prediction. Okay, these AI models do prediction. Now, if I talk specifically with terms of computer vision, we have amazing applications in computer vision. I would like to show you that. So I will go here on my LinkedIn, and I'm gonna search this guy, Shah Faisal. There's a good guy. He's a freelancer. He's making good solutions. So let us just look at some of the solutions. They are very interesting. So I'm just gonna scroll down over his feed. So see, he has made a application which is going to track your exercise. Are you doing it correctly, and everything. Pose detection, pose estimation. That all is coming into the picture. Now, secondly, look at this solution, wherein your vehicles are being detected, pedestrians are being detected, and everything is happening nice way. And here we are also getting a scene map of how it is happening. See, this is so beautiful, right? So these are the kind of solutions he is making for people. I'm going to show you more. Intruder detection. So see, he has made something. He has made some area wherein you are going to detect a few things, etc., etc. See, car has parked, someone is entering the gate, someone is trying to break in, right? He's detecting all of that. And see, once it has break in, it's gonna get detected. Okay, see, this is how it's gonna work, right? If I show you next solution, Check this out, right? So you guys are able to see my screen, right? You're not sharing. I can only see blackboards. Let me see. So you can only see my blackboard. All right. So blackboard was visible, right? Everything that you saw on the blackboard was clear, right? All right, all right, all right. Let us look at these solutions now. Check this solution out where we are estimating the position of a particular person, and he is, we are doing the body tracking and everything, pose estimation, and we are seeing if he is working out correctly. Then we are seeing that how it is detecting all the pedestrians and the cars and everything on a particular road, right? This is for the government. And see, proper tracing is also given, that how many people, cars and everything is happening. Next, if I show you this intruder detection, right? We also have an emergency dialer. We have captured intruders. We have some area that no one should enter this area after this particular time, and if someone is entering, there is something wrong. So we can see this guy is entering. This guy is trying to break in. All right, this guy is trying to sneak in, and once this guy will sneak in, we will be able to do something. See, it is automatically dialing the police. This is the real automation, right? This is the kind of solutions people want, right? We will see more of these. See, here he has built a drone powering system. So here it is tracking everything from a real height, and see how it is performing all the detections. Small, on a very smaller level, it is detecting everything. Then this is also amazing. See, check this out. Traffic analysis, complete traffic analysis. It is able to trace such good details, right? We are just going to continue seeing more of these so that we have a very good understanding of what real computer vision is. Okay, we have been diving in the world of agentic AI lately, but this is real computer vision, right? This research is going non-stop and amazing. See, object tracking and copy detection, cheating detection, right? If they are trying to cheat, cheating is detecting, right? How are we developing all of this, right? Now here, a medical use case. Every use case you talk about, there will be a use case for that. Okay, let me see more interesting ones. I like the game tracking ones. These game tracking ones are really nice. I admire them. That how they are able to trace the entire maps. There is a specific. I started this project by exploring. There's a specific word for that. I'm not able to come to that. But yes, you guys get the point.
For this project, I developed a complete smart parking management system.
You guys get the point that this is how things are working. This is how different solutions are being developed in the computer vision world. There is one more different world I would like to show you. Currently, in the recent advancements, there are different worlds which are expanding heavily. So currently, I was showing you AI computer vision world, right? I want to show you another world. Of course, it is not anywhere related to computer vision. I want to show you some world of neuroscience. Okay, neuroscience. This is the world of electronics. Okay, electronics. Imagine you think that you want to turn the lights on in your room and you turn it on, right? Imagine that you want to turn that mixer on with your brain. It is happening. Imagine that you are playing a chess game with your brain. You are moving each of the pieces with the brain. Imagine you are typing with your brain. You are thinking and it is being typed. Okay, you are streaming by your brain now. Okay, this will be amazing. Okay, I'm taking this towards neuroscience. I would like to show you something really interesting. This is Upside Down Labs. Okay, this is an organization which is developing neuroscience kits. You can buy those kits and play it. This is not a commercialized advertisement. This is something I want to show you. Using your brain, they are trying to do something. Okay, this is just some other stuff. See, and using their hands also, they are playing some games. Let me show you. So see, with hands, it is playing all these different games. they have really good solutions down there. Let me show you more good solutions. You can definitely check this out. I see, using this brain, she's making those bubbles and everything. And let me show you something good. Yeah, let us see this. See, with hands, she's playing all of this, right? This is neuroscience, where you are detecting the neural behavior of your body. So yes, please check this out. They are also doing amazing work. Okay, this is the kind of kit they give, and they give it for home development. So which industry I'm talking about? I'm talking about IoT industry. Okay, and IoT industry is also adopting AI very heavily, and that is called as industry 4.0, the fourth revolution of industry. And today we are understanding OpenCV 5.0, which is the fifth revolution in the OpenCV game. Okay, so let me show you the page right here. I'm now coming to the topic. We are talking about OpenCV 5. Okay, I'm gonna read this. OpenCV 5 is one of the most important releases in the history of OpenCV. Why? Because after 2018, okay, 2018, now is the next release of their model. Till 2018 and till now, from 2018 till 2026, they were releasing, more versions of fourth version, 4.8, 4.9, 4.1.6.8, something, something. They were continuing their fourth version. This OpenCV version 5 is a very big leap in their particular, in their particular history. And for more than 2 decades, OpenCV has been the foundation for computer vision. So we know OpenCV is the oldest. Since the computer vision was born, OpenCV was there, okay, from more than 2 decades. Where it is used in robotics, it is used in embedded vision, which means small devices, AI application, industrial inspection, okay, AR, VR, medical imaging, countless production systems. OpenCV is used. Okay, there was no other alternative of OpenCV. Today, the library has more than 86,000 GitHub stars and more than million installs per day. Million installs per day. And one of the largest collection of computer vision algorithms in the world. Okay, this is OpenCV. Now, OpenCV 5 builds on the foundation with major modernization in the library. It brings new DNN, which means Deep Neural Network Engine, stronger ONNX support. I will be talking about this specifically. I will be talking about only two things today in the class: DNN and ONNX support. Okay, hardware acceleration, it comes after that. Python integration with new data types, expanded 3D vision capabilities, improved documentation, and a cleaner architecture for the future. Okay, so computer vision has changed dramatically since OpenCV 4 is what we want to understand. Okay, what happened, why there was a need for OpenCV 5, okay, why they had to reproduce their systems. Okay, that is what we are going to talk about right now. So let me go here, and I'm talking about it. So first of all, where is OpenCV used? I was speaking that deep learning, okay, deep learning is all about giving birth to new AI models, right? So let us say we are developing a simple use case where, given an image, let us say this is a cat image, okay, a very classic use case, the kind of use case which used to, we used to learn in our initial days. Let us say we have a cat, given a cat image to our AI model, okay, to our deep learning AI model, okay, or a CNN model, computer vision model. Okay, we want to predict that if this is a cat or a dog. Okay, cat or a dog. This is a very simple problem statement I'm talking about. Now, what is the role of computer vision over here? Because we know to train deep learning neural networks, we have two frameworks. One is PyTorch and one is TensorFlow. Okay, these are the two frameworks using which we train our deep learning models. Now, before training, what happens? Before training, data pre-processing happens. Okay, data pre-processing happens before training, right? And before prediction also, what happens? Before prediction as well, data pre-processing happens, which means this was only model training. When you are deploying this application in your software or on your hardware, whenever an input comes, it has to processed. It has to be processed, right? And that processing is done by OpenCV. It is involved in data pre-processing, which means what are things it includes? Data resizing, right? Data augmentation, right? Capturing the dynamics of an image, right? Capturing brightness, whatnot of the image, cropping the image. Okay, so you can do a simple plain search that what what all tasks we do in OpenCV. Okay, it will tell you all the tasks. You can read the image, you can write the image, you can read videos, right? Geometric transformations, crop, rotate, translate, flip images, switch between colors, RGB. So that field is called as graphic. I'm not able to recall. There was a specific field before computer vision. It was understanding of graphics. Okay, filtering and blurring. You can do all these kinds of things. This is helping in data augmentation, feature detection analysis, contour detection. Object detection is contour detection, feature matching. Everything you can do with OpenCV. There is no solution made without OpenCV. But what was happening? Now we know what is OpenCV. Okay, what was happening? Now OpenCV was good. OpenCV was helping you all for data pre-processing, etc. Okay, it was good for prediction, right? So how it used to use it, how it used to happen is we used to load a deep learning model, okay, and we used to do the inference. Inference means prediction. Okay, prediction. Now where we used to load this model, and we used to plug it in with OpenCV, okay, which means the processed input will go into our deep learning model. But what has happened over the years? Now, what I'm telling, remember, after 2018, there was no update in OpenCV. But what has happened in the learning industry? What has happened in the deep learning industry after 2018? We have skyrocketed our deep learning models, which means research. Okay, OpenCV is there itself, but research has skyrocketed. What research has made? Vision language models, diffusion models. Okay, they have made all these different kind of things. What is a vision model? Okay, which will you can give an image. Okay, you can give an image and you can say describe this image, which you guys have been doing with ChatGPT, or give some prompt and do something with the image. Okay, maybe use it for any use case, medical use case, image generated descriptions, vision language models. Okay, we have vision transformers, VITs. So why this happened? Because of the rise in hardware, it is of course that our deep learning models have advanced. We are touching mad accuracies. There is no limit to the accuracies we are touching. But where are we failing? We are failing in deployment part. Why are we failing in deployment part is now we want to understand, and this is the whole reason of having OpenCV 5 in the industry. Now, these advanced model, again, what is diffusion model? Diffusion models are the image generation models, which means you might have seen in an iPhone, if you capture an image, you capture an image of a person and there is a person behind it, you will just highlight this image and you will say that remove this person, and it will automatically go off. Okay, diffusion models in action. All right, so what has happened? Research is skyrocketed with all these new research, but what was stopping deployment? Deployment means people to be able to use these models. Okay, people to be able to use these models. What if you want to make, now I'm jumping to a use case. What if you want, what if you have spent days in training a YOLO model for object detection, right? Now your boss tells you, I need to run this object detection model in a mobile phone. You'll go crazy. You'll say that, oh my God, how will I do it? Right? Now, OpenCV was compatible everywhere because we were writing packages. Now, what was happening with OpenCV was these new models. Now I'm talking about the point. these new research advanced models, what actually happens with these models is over the fly, these models change their shapes. Okay. The input shapes are changing because when we go in our transformers architecture in the vision language models, the shapes are changing internally so that we can do better processing, right? And internally, the computation is also, happening in a different way, not in a standard way. Computations are also getting dynamic internally. Okay. And this was not getting adopted in OpenCV 4. It was too much for OpenCV 4. OpenCV 4 was not able to handle it. Why? Because OpenCV 4 is very old. All the dependencies were on C++ written libraries, Python 2 dependencies. Okay. Older C++ versions, legacy codes, these all were running in OpenCV 4. Because of which this was impossible. We were not able to do this. And we were not able to use our latest models here because OpenCV was not able to handle it. Okay. And this gave rise to OpenCV 5. What happened in OpenCV 5? We completely removed these things. Old C++ dependencies. C++ is not gone. Okay. C++ is the base on top of which OpenCV is made. Python 2 dependency is completely gone. Okay. And in OpenCV 5, they have brought in a new thing. They have basically changed majorly their deep neural network engine. That engine which is responsible for processing your predictions, for inferencing. Okay. For inferencing, this is what I'm talking about. Okay. This is the kind of change they have made, and this is what they write in their particular docs, that modern applications with classical vision, deep learning transformers, large vision models, edge deployment, heterogeneous hardware, which means mobile phone, Raspberry Pi, NVIDIA, Jetson Nano, right? Python first workflows. Developers expect the same code to run efficiently everywhere. Okay. But this was not happening. And that is why OpenCV is come to meet that reality. Okay. Now let us have a good time. Let us have a good time understanding the outputs. Okay. I've made some application for you guys. You can test it. So I'm going to show you live demo how fast the inferencing runs. Okay. And they have got new things into this. What kind of new things they have put in? Earlier I showed you that OpenCV was for reading images, resizing, flipping the images. It was not able to do any kind of those things which modern computer vision applications do. But with new advancement, they have also added new things which I would like to show you. These are some new things. I will give you this application to test as well, but first let us enjoy the demonstration. Okay. Now this is colorize. Let me go to colorization. So what we can do is I can just pick a black and white image. This is me. This is an AI generated image. All right. I love music. I love sound engineering. So this is a black and white image of me, AI generated. Okay. And this is the colorized version of it, which means it will predict what can I make. Okay. What color to put in this particular location. For example, let me show you something else. Okay. Let me show you this sunflower image. See, it will color this sunflower and how fast it is doing. Okay, this is what we want to understand. See, it is printing 251 milliseconds. Okay, in 251 milliseconds it processed the colors. It thought which colors it would be the best and it did it. So colorization is coming into the picture. Now object detection, see how fast detection will happen. So I will go here in the this will also be provided to you. Let me go in the inputs, images, and let me pick some image where we can do some detections. Okay, so see, I've dropped an image and see how fast it will process. See, detected the bus person. Okay, it loaded a raw YOLO model. 48 milliseconds for detection. That's it. Okay, this is the kind of speed we want. Okay, after OpenCV 5, the computer vision applications are going to skyrocket. Okay, this is detection in a video as well. Okay, let us see a video. I will go here, I will go to videos, and I can just put in a video where there are multiple people walking. Let us see that. Max frame to process. See how fast frames will process. See, this is the kind of speed on which frames are getting processed. This is amazing. Okay, this is just amazing. All right, and now see, let us look at this demo. People detected, right? It processed all the frames, and now all the people, truck, car, everything is getting detected, just how we detected that thing, right? Now, super resolution, enhancing the image quality. So this will be so important while data generation, right? Synthetic data generation, so we can take this Lena image. Okay, we can see how super resolution works, how it will enhance the image. This will be super important because when we are feeding images to our deep learning models, we can directly feed good kind of images, right? See, resolution is increased. Okay, background removal. Okay, how background removal works, I will show you how it fails also. I mean, let us see this. Okay, let us pick this image, squirrel only, no worries. See how background removal works and how fast it works. Okay, background detected so fast, right? This is the kind of speed we are getting with OpenCV, and this was not possible with OpenCV 4. Edge detection. Okay, I'm gonna go here, I'm gonna pick a butterfly, and we are going to spot all the edges of a butterfly. Okay, this is gonna be very interesting. So see, it is running that, and see, edges are detected, right? Feature extraction, right? It is happening. Okay, portrait matching. Now I'm just gonna pick Messi's image over here, and we can isolate objects from an image as well, right? Now there are endless possibilities. It is downloading the model first. I will tell you how it is downloading, but see, isolating the particular objects, amazing. Segment anything did not work due to hardware constraints. There is also something called as in painting. Okay, let us see if this works. I think it was giving me some error earlier, but let us see if it works. I've just dropped in an image. Okay, I've programmed it in a certain way. Usually you just highlight the place that you want to inpaint, but I've programmed it that I will feed an image, you will detect the persons, and we will remove that particular person. So I am trying to remove this particular person. I will go here. This is the person, fourth person. Let us see. It will catch, it should catch this particular person. That is catched. Now we will remove this. Okay, so let it run. The inference should run, and let us see the output now. Okay, it's downloading the model, loading the model, and what it's going to do is it's going to remove this particular person from the image. Okay, so we can wait for a second or so. It's gonna happen. Okay, last time I was trying this, it crashed because I'm not running this on my computer. This is running live on cloud, Streamlit Cloud, where there are some hardware constraints. So it can possibly fail this time as well. But let us see if it is working. Okay, it is working. It is working. No worries. Okay, and let us see the results. All right, it crashed. No worries. What I can do is I can just reboot the application in 1 second. So this happens. I'm specifically showing you this error so that if you come with this error, so you can solve it. Now why this crashed? Because I'm running this application on Streamlit Cloud so that I can share with you audience. Now Streamlit Cloud gives you some restrictions on running this. If I was running this on my local computer, no, it will not give me any error. What happens is the memory, the RAM gets filled up very fast. Okay, Streamlit is not usually made for so many things. I'm loading so many models, 1 2 3 4 5 6 7 8 10 models. Okay, so let us again do it. I'm just gonna put in this image. We will try to do the in painting. I will again pick up the same task itself. Let us be patient. I will call the fourth guy, and now it will run fast because the I have rebooted it, right? Because everything is cleaned up. So let us see that in action. Okay, let it run. It should run. And of course, I've provided you the GitHub of all of this. This is my GitHub. I've provided you all of this OpenCV webinar. So what you can do is you can just simply see the steps, okay, how to run this. I've given you good things. If you go in the experiment notebooks, this is where, please pay attention. I've given you small things, that how you load a YOLO model, how you run all these experiments. This is just running in a Streamlit file. But see, how do you run all the experiments? See, if I go here, if I go to the part 3, there are different parts I've made. Everything I've made it for you. Okay, you can just use it, watch it. See, 2 images loaded, colorization, detection, okay, object detection in an image, super resolution, everything I have provided to you. Okay, you can watch it. See, in this part 4 also, everything I've provided to you, which means first do the experiments. Once you succeed in your experiments, then go for running the application. Okay, now one more exciting part. I have given you something called as docs. In this, there is in and out about OpenCV 5. Check this out. Index, which means the index page. What is OpenCV? Why OpenCV 5? Breaking changes, modules, new DNN engine, new data types, live class walkthrough, troubleshooting, where the models come from. So how this Streamlit app is running? See, that person is gone from here. Okay, earlier this person was here. This person is gone. In painting in action. Now, how am I running this application? How am I running this on cloud, and how I can, anyone who has access to this particular link can access it? I have hosted all my models on Hugging Face. All the models which I'm supposed to run, they are running on Hugging Face. And I'm inferencing via Hugging Face on Streamlit. So this is the classic way of showing your prototypes to any of your clients without investing in any cloud technology. So this is the best open source solutions. Streamlit app, how you are supposed to use this Streamlit app, experiment colorization, background, in painting, every single experiment I've broken it down. There is some good explanation for that with input output and everything that you need basically. So yes, that is the documentation also provided. This is the OpenCV, what do you say, this is the OpenCV main blog page, June 4, which is really recent. Okay, this is the OpenCV repository where you will be able to find all the things, which means where did I learn from. Okay, here you will be able to see the OpenCV community repository. You can see what is entire OpenCV, and this is their particular page of development. Okay, this is their intro page, and this is their particular page. You can see 90.6k stars. It is a very huge community, good community. Okay, so yes, this is amazing. All right, now we know the demonstration. Now we know how fast the OpenCV models are running this time, the new deep neural network engines and everything. And now we are good to understand this part. We are good to understand this particular part, ONNX support and the deep neural network engine. This is what we are going to understand now. Now, given the understanding of everything, that why there was a need of OpenCV 5 and what kind of outputs we were expecting from OpenCV 5, we are done. Okay, we have seen all these experiments, we are good to go. Now we will go ahead and understand very important things, which is ONNX and deep neural network engine. Okay, two things. Now, what is ONNX? Okay, the full form of ONNX is Open Neural Network Exchange. Okay, Open Neural Network Exchange. What do I mean by that? So see, you are making a model on your very high expensive hardware, but that is not where we want to use it. We want to use it in a CCTV camera, on an edge device. We want to use it in a simple mobile device for augmented reality or whatnot, right? We want to use it in different scenarios. We want to integrate it with machines. All right, so that is where the bottleneck comes, that once you train your models, how do you fit it on smartphone? I'm just picking up that use case because I was talking about it, right? So ONNX is the answer. We know the full form is Open Neural Network Exchange. What is this? So you can understand this Open Neural Network Exchange as a PDF of neural network models. Okay, what do I mean by that? Let me take this and understand you. We train deep learning models. We train it using either PyTorch, okay, or we either train it using TensorFlow. Okay, there was a C version of Torch as well, so that is why I specifically write PyTorch, because we train these days we train it with Python Torch libraries. Now, whenever you train models using TensorFlow or PyTorch, okay, you load it using TensorFlow or PyTorch only, okay, because TensorFlow gave that model as output and PyTorch gave that model as output. So your model was always stuck in that ecosystem only. You have to understand, okay. Every time you train a new model, you will be stuck in that ecosystem. For example, I took this particular example of a cat. Where is it? A very simple example, I was talking about a cat. You trained this model, you trained it using PyTorch. Now, when you will be making a Streamlit app or whatever kind of app to predict that this is cat or not, you will have to import TensorFlow and you will have to import PyTorch, which means you have to be dependent on that ecosystem. But what if? What if? So, hardware, if I show you the hardware, okay, let me go and show you Raspberry Pi. The kind of memory it comes with, okay, yes, we can expand it to 512 GBs, which is good, but what this little guy will process, okay, if we install very heavy libraries on it, this will go crazy, right? So we don't want that, right? Yes, we can run it, we can install it, but we should not install it because these libraries are very heavy. Okay, these libraries can occupy the entire space of your particular hardware, and of course we want to store images on hardware, we want to process machines, we want to run our machines from this hardware. So again, occupying the storage will not be the best idea. So we were relied on this particular ecosystem. Even when we were running on Android, okay, we had to run compatible packages so that we because it was trained here. So this was what we were locked in because of the ecosystem. We did not have a chance. Now what happened is Open Neural Network Exchange happened. This is a format, okay, format to represent your neural network. What this is going to do, ONNX, let us say you train a deep learning model. Okay, this is how a neural network looks like. Okay, I'm making this after so long, feels really good. Okay, it's almost after a year I'm making this diagram. So I made this neural network using PyTorch. Now I want to run this in my Raspberry Pi device. Okay, what I will do is I will convert this into ONNX first, and I will use this ONNX in Raspberry Pi. What ONNX is going to do? ONNX is going to capture all these neural network graphs. It is going to capture what inputs are taken, what outputs are taken, and many more things. So it is going to capture all the computation related information in a specific format, and we can use this in Raspberry Pi without being dependent upon PyTorch or TensorFlow. And this is how it works. Okay, this is a PDF of your neural networks. So let us say you use your Microsoft Docs, okay, to write some docs, and when you open this in Apple iOS, the format is changed. Even when you open this in Android, the format is changed because their processing is different. Okay, so I will talk about the format also, how it looks like, what all things it contains. Okay, if you want to know the format, it is .onnx, but ONNX. Okay, but what's inside it, I will talk about it. Okay, we will of course come there, but before that let us understand that it is a PDF of Docs and Apple. It is a PDF of, it is a PDF of neural networks, which means, let us say you wrote a docs. If you convert it into a PDF, if it will open in a similar way here, it will open in a similar way here and anywhere else. We are locking in the information. Okay, so that is what it is doing. ONNX is locking in the neural network information. Let us go to the slides. Now we will understand four things. We already understood the interoperability crisis. Okay, so interoperability crisis means many to many nightmare. People were fed up that I trained my model here, I trained my model here. How do I connect it in my IoT systems? They had to write lot of logics, they had to do lot of optimizations, but then ONNX came. It will run the same on your GPU hardware, same on your iPhone, same on your Android, same on your laptop, same on your server, same on your edge device. Everywhere it will run the same. Okay, ONNX. So ONNX solves the interoperability crisis, which means train it anywhere, run it anywhere. Okay. ONNX is an open standard representing the machine learning models as a framework independent format. Okay. Now, anatomy of ONNX files. What is exactly captured in this format? How can we use it somewhere else? So, four things are captured. First, the neural network. The entire neural network is captured. That what are the inputs, how are the inputs, all the layers, everything is captured. So, first thing done, neural network captured. Second thing, mathematical operations. So what is mathematical operations? Inside a neural network, we do computations. For example, ReLU, right? We do activations, we do optimizers, right? So for for all of that configurations, mathematical operations, we have another part. It is storing neural network. It is storing all the mathematical operations which are done. Okay, not it is what going to do, which are done. And why we need it, which are done, because then we can do prediction on top of that, right? Second is learned weights and biases, the most important thing, initializers. What does a neural network learn after everything, after all the training period? It learns weights and biases. Okay, what it is doing in every epoch, front and back, forward, backward, it is learning weights and biases. Okay, offset is versioned operator definitions, which means what this exactly means is we are defining such configurations which will run on any hardware. The fourth part of what ONNX format contains is writing a configuration which will be compatible for each of the device. So the moment it ONNX is going over there, okay, that device will automatically pick up the ONNX. Okay, that is what it means. Versioned operator definitions. Who is going to operate that model? So we are going to define for that, and that is what ONNX is: Open Neural Network Exchange format. Now, what exactly does graph optimizations? Okay, ONNX is helping us in graph optimizations. All right, how graph optimizations work? We have already captured this neural network in ONNX format. We only want to run this. So ONNX is, computing that very fast. Okay. How it used to work earlier, when we used to take normal TensorFlow model or a PyTorch model, we used to run convolutions, batch normalization, ReLU activations for all of our inputs. Okay. But now what happens is, because of ONNX, all of this is fused into one, and we directly pass into a single pass. Okay, this is what ONNX did with us. Okay, this is what ONNX did with us, and all of this information is fused in that particular hardware where we are running it. Okay, see, ReLU activation, batch normalization, convolution. So neural network, mathematical operations, and this is also, mathematical operations as well. This is all is interlinked. Now what all things it does? It does, activation fusions, which means ReLU activation. These all things it does. Normalization task, so that we can preserve the context. Hardware specific layout optimizations, which means for a specific hardware how it is going to run. Okay, this is what ONNX does. Now how ONNX runs? So to run ONNX on any hardware, we have ONNX runtime. Okay, ONNX runtime is the one which is responsible in running the ONNX file. Okay, Now, how it does is, we have two ways to run it. One way, you know how I was running this particular application, this particular demo. So whenever I was running this particular application, you can see your app is throttled. So it is going more than CPU. Let us forget this. Let us remember. See, I was saying that how ONNX runtime works in two ways. First way is, whenever you run it for the first time, it is going to download a model. Okay, if I just upload a black and white image over here for colorization, it will first download a model, downloading the model, and then it will run the inference. So this was pretty fast. It downloaded the ONNX model and ran the inference in such milliseconds. What I want to show is that every time you will run it, it will pull it every time. But we can say that whenever you are running for the first time, then only pull it. Rest, save it in your memory. So now it will not download the model. Now it will directly run. So let me show you. Black and white image, my black and white image, zip zap, 1 second, ran. It did not download the model. But when we run this specific thing for the first time, okay, if I take this particular image and I will run this for the first time, okay, so it will download the model and then it will run it. And next time it will not download it. So this is the two ways how ONNX runtime works. And this is the best way to run this, okay, because that will be a hardware. That hardware will not have internet or something to download the models, right? So we will always store the serialized optimized graph to the disk. We will not always download it on runtime. First time, yes, download it. But after that, always directly run it from the disk memory. Don't do it. So that is what I was doing it over here. See resolution, we can see good resolution increase. It is much more precise. Okay. And that is how it works. And this is how an entire pipeline will work that I was speaking about. If your boss said that the model, YOLO model, which you have trained on PyTorch, you want to run it on an Android. So what you will do, you will export it to ONNX format. ONNX format will be optimized because it will fuse your graphs, your everything which I was talking about. See this part, it will fuse all of this into one. That is how it is optimized. And once it is optimized, we will directly run in our native hardware. It can be a GPU, it can be a server, it can be an Android application. Okay. Now how this works, okay? Execution providers for hardware. Okay, this is what I was talking about. We already have a specified configuration that the moment ONNX format enters, it will automatically pick up the hardware configurations and it will automatically run it. Let us again understand this. What will happen the moment we run this ONNX model, okay, it will directly find the hardware of the specific processor. Now this is my computer, so it will target the CPU automatically. Now this is this is GPU, so it will target the GPU automatically. And this is the chip of the mobile, Snapdragon, right? So it will capture that Snapdragon thing automatically, the mobile chip automatically. Okay, so this has a specific term that how it will automatically target the hardware of, how it will automatically target the processor of the specific hardware. It has a specific term. The term is called as execution provider. Okay, execution provider, it is called as EPs. We have EPs in ONNX for hardware acceleration. Okay, so I can do a simple Google search that why are EPs, now we know the word, so we can flex it. Now why are EPs used in ONNX in simple words? So your Gemini LLM is gonna run. Execution providers in ONNX are specially the plugins or translator to tell ONNX how to run your AI model on a specific hardware. So you don't have to worry about it. ONNX will take care of it. Okay, hardware optimization, write once, run anywhere. Check this out, write once, run anywhere. Smart delegation, which means AI model to the hardware acceleration, right? And this is this execution providers. And just in case, even though you have converted your ONNX model, your AI model into ONNX model, so if its size is too much, which is not, and your hardware is too small, Do you have a solution for that? Yes. The solution is called quantization. Okay, you will quantize your model and that will run on your hardware automatically. Okay, so quantization is also a field of research in deep learning. It is very heavily being researched, quantization. Okay, Q LoRa, everything that you can see. So the whole purpose is your model ready for the real world, and that is why you use ONNX. So now that we understand about ONNX format correctly, I'm gonna go to making you understand what is the new thing in OpenCV 5. Okay, what is the new thing in OpenCV 5? So the new thing in OpenCV 5, all right, is the deep neural network engine. They have made a new engine to process deep neural network models. Okay, this is called deep neural network engine. Okay, now how does that work? The question is, how do you run tomorrow's AI on today's hardware? This is so good. Okay, what is tomorrow's AI? So vision language models, right? And all of that is the future AI. I mean, we never thought that we will see it so soon. We were all in the understanding deep learning, and one fine day now we have transformers. We are generating content, we are doing everything with AI. So this is the future of AI, right? And is it ready for our hardware? Is that computer vision ready for our hardware, right? This is what we want to understand. Why? Because research is skyrocketing. Why research is skyrocketing? Because hardware is updating, GPUs are updating day by day, right? And that is why accuracy of the models will increase, because better brains or better grasping of the things, better processing, better outputs, better accuracy. So people are going on training complex heavy models, but have you ever thought, how will you run it on a mobile? How will you run it on a small device? That is where the bottleneck comes. That even though you have trained such a good model, but of what use this model is? Now the answer is better inferencing. This is the answer. Okay, let us go ahead. So we know about vision language models. AI is running end to end to analyze images. All right, you feed an image to ChatGPT and it is going to give you all the answers in the world. All right. So the first thing OpenCV added was ONNX translator. Earlier, what was happening is those these kind of models were not running on OpenCV 4 because they did not have the perfect compatibility for ONNX. So the first thing they did was they updated their engine, and the first kind of update they brought in was support ONNX. This is what they did. Okay. So why did they brought this particular update? Because the model was trapped in the particular ecosystem. PyTorch, TensorFlow model was trapped over there. We wanted a universal format. So ONNX they brought it into the picture, and this is what was blocking, because OpenCV 4 was not compatible with the tomorrow's AI models, which means vision transformers, vision language models. People people want to make their use case. Client is coming with the requirement, and your CEO is accepting that, okay, I will do it. CEO doesn't knows what is happening with OpenCV, right? So CEO has accepted this, and now developers want to work with this. CEO will say that, hey, vision models are there, why not make it? Okay. So now it was a challenge to developer. They were entering this duct tape area. Okay, what is this duct tape area? Wherein whatever they had to wrap up. Okay, they had to wrap up whatever hardware they have in whatever way to deliver the client. Why? Because OpenCV 4 was not compatible with ONNX. Out of all the solutions, the rate was only 23%. So if you had 100 models to run, OpenCV 4 was taking only 23% of it. Only 23 models were running. Okay. And OpenCV 5, yes, is the LLM era. Okay. Now, OpenCV 5 was failing because what happens is, I'm telling you now why OpenCV 4 was failing. Okay. Because traditional systems were not able to capture the different shapes which were changed in neural network. Now, if you have ever seen the transformers architecture, internally The shapes are changing very rapidly because that is the kind of logic we have said. Attention mechanisms, right? That was not happening. They were not able to capture the subgraphs, internal graphs, residual layers. We were not able to capture that. Okay. And that is why, OpenCV 4 was not supporting that all right. We were not able to adapt to that format, and we entered the duct tape area where we were just kind of in a way writing logics from scratch, just wrapping up the things so that it works, just to make it work. That was the sad part of using OpenCV 4. Okay, heavy ONNX runtime integrations, writing custom glue code. Okay, bloated application sizes. The apps were very big. Okay, let us say you are releasing an application on Play Store and it is the size of 2 GBs, 3 GBs. Okay, that is not good, right? Major developer friction. Developers were sad, and OpenCV 5 changes everything. And you see, future is gonna be something else. Future is gonna be mad. Okay, and once OpenCV 5 came into the picture, the ONNX format rise. I mean, the model percentage increased from 22 to 80%. This is almost very high. 20%, 20 to 20, 100, 200, 300%. Okay, we are able to see it. 400% maybe. We are able to see it, right? Now it just works right off the box. Okay, we just saw those examples. Everything was running, diffusion was running, right? That, what was that coloration? That was diffusion running. Okay, now new engine features coexist with classical engine. The previous engine is also there, which means the people who are already using OpenCV 4 in their solutions, so nothing will be disturbed over there. They have just made a better engine. Okay, native vision language model support built in. This is the part which changed the new deep learning engine. These are the kind of updates I'm talking about. Includes tokens and attentions. So this is what I'm talking about, continuous changing shapes in neural networks. It includes tokens and attention processing, and removes cafe and darknet, which is the old kind of dependencies which were which were used for pre-processing earlier. Okay, darknet and cafe were the old pre-processing techniques by OpenCV. So what comprises of the new OpenCV 5? It has the new engine, which means the moment you load a model, it will first go to the new engine. Okay, if the new engine was able to load it, good. But if the new engine was not able to load it, which means now we said that pre-processing will be with tokens and attentions, right? If it will not be able to load it, which means it will not be a vision model, it will not be an advanced model, it will automatically fall back to its classic engine. Similarly, right? And open ONNX runtime is integrated. This is how they brought ONNX into the picture. This is how they got ONNX into OpenCV 5. ONNX runtime integrated. Okay, and they posted the proofs in the benchmarks. So they compared OpenCV 5 with ONNX runtime. They ran it on another hardware. It was good. It was giving good competition. Okay, VIT base, YOLO V8, these are heavy models. Okay, mobile VNet, OpenCV and OpenCV 5 and ONNX runtime. We tried to run it on a hardware. Okay, see, it was running as good as running on a CPU. All right, and the last thing is, with this new engine, we don't know what not people will be doing in this particular world. And yes, that brings us to the end of this particular lecture, the end of this particular class. We now understand OpenCV 5. We very well know what is ONNX. And now if we go ahead and read this particular line, now if we again read this, OpenCV 5 builds on the foundation with a major modernization in the library. It brings a new DNN engine. We know what kind of updates are brought in. Stronger ONNX support, which means ONNX runtime integration. Okay, hardware acceleration, because ONNX automatically accelerates the hardware. Improvements, better Python integration and new data types, expanded 3D vision capabilities, improved documentation, and a cleaner architecture for the future. And this is what brings us to the end of this class. So I'm going to show you something very important. If you guys don't know deep learning, because that is the real AI, okay, engineering, that you have to be independent, future ready. Okay, And I just want to show you this particular thing. We are launching the 3.0 batch of our data science and engineering. Here we will go completely into deep learning, computer vision, NLP, everything will come. Okay. And learning to train models is very important. We also have an advanced batch going on where we are learning how to make those models of tomorrow's LLM, tomorrow's AI, which means training vision language models. You can see over here training transformers, training vision transformers, quantization, which I was talking about. So we have an advanced batch going on already. This is only if you have the knowledge of deep learning already. But if you don't have the knowledge of deep learning, I will suggest go for this particular batch, 3.0 data science batch. This will be amazing for you. Okay, here you can learn the deep learning end to end. And yes, that was it. All right, guys, I hope you enjoyed this. It was a very interesting session this time. And see you in the future videos. Until then, take care. Bye bye. Live your life.